Hello everyone, in this video we will discuss the step 7, how to set up the scope trend for the setpoint input-output of the PID. And based on the previous video, we programmed the PID function block. Also, we used one second-order mathematical model as our controlled object. We connect the PID and this mathematical model, control them together as a closed-loop system. And in this video, I will download all of those function block and the program and run in my laptop and use the simulated function of the TwinCAD software. And then I will set up the scope or trend to monitor the setpoint, input, and output of the PID. And in this video, I will use my laptop running as the controller and download the TwinCAD 3 program into my laptop and run this PID and this mathematical model. And to monitor the input and output of the PID, so we will set up the scope or trend to monitor the setpoint, input, output of the PID. Okay, let me show how can we do that. Okay, this is the key program PID_call. In this call program, it called the PID controller and this simulation process. That is a second order system. And this PID_call will be organized by this cyclic task, that is 100 milliseconds. And all of those programs already programmed by the previous video. In this video, we will firstly set up something around here to allow my laptop can run this controller, can run this program. And then I will set up the online trend. And currently, I'm using the virtual machine as the system, and to allow this virtual machine to run this program as a simulated controller. Firstly, I need to go to the license first, check out if my computer, this license is activate. As a learning purpose, we can use the 7 days trial license as shown here. The current license already expired, but don't worry, we can press this button to activate 7 days trial license. Firstly, we can see the current license, the trial license in my laptop, they all expired. So we can press this key and type in GBASH, click OK. So we can refresh this page. So we will see, now this is a new expired date. So it gives me 7 days trial license. That is a very good feature. So for the learning purpose or test wheel, we can use 7 days trial license to test everything. Currently, I'm using my virtual machine as a system. To allow this virtual machine to run this TwinCAD program, I need to go to the real time, double click the real time, and check out here. If you are running in your host machine, so this core represents the core of your CPU. However, if you are using the virtual machine, so firstly, we can click this read from the target. It will read the current courses from your virtual machine. Because I assigned 4 courses to this virtual machine, so it shows 4. Firstly, we need to click this read from the target. And then keep in mind, here, isolated, we need to select this isolated rather than this. That means we need to assign the one isolated core of your CPU to assign to run this TwinCAD 3 controller. So we need to select this. And after we select this, default, so all of those tasks like this, 100 milliseconds that we set, and this PLC task, they all assign to this isolated core. So after we select this, we need to click this set on target. Set the new numbers of the shared course on target. Yes, okay. And then personally, I recommend you better restart this TwinCAD software. Okay, once you reboot your project, so you can double click this real time, check out if everything is set here. So it selected the isolated core, which is correct. Okay, this allows our virtual machine can run this TwinCAD project. Okay, after this, we can download, click this, before we run our project using this virtual machine, we also need to disable this EtherCAD because we are going to run the simulation only, run the program only. So we need to click this disable. We need to disable this. Okay, and then let's build this project. No errors. And from here, we can click this button downstairs, activate configuration. Restart to run mode. And watch this icon here. If your controller is stopped or in configuration mode, it will show the blue. Once it's start, it will run. It will show as a green here. It's a rebooting. Okay, now there's a small yellow gear running inside. It shows a green. That means this simulated controller is started. And now the controller haven't run yet because we haven't logged in our program. Currently, only hardware is running. To allow this simulated controller to run our software, we need to click this button, log in. Once we log in, that means we download the software. Okay, to download our program, we can click this PLC and click this login. And once we click this login, we will download the program to this simulated controller. And here it shows it's running. That means everything is running. Without any hardware, we only use our laptop to run this program. And now we can set up our watch table to monitor the key parameters or key values. Firstly, let's set up the set point. So set point, we can click here and click this add watch. This is our watch table. We can dot this table at here. Okay, this is a set point. I could also add this global value, this set point global value. Okay, I can delete this line, they are the same. Okay, value to scope, this is our set point, and this is the actual value, come from our simulated value. So let's click this add watch. And the PID output, that is this. We transfer the PID output F out to this scope. Add watch. And also we better monitor the control mode. Okay, E mode. Add watch. And now it shows in auto mode. Okay. Okay, those are the basic key values for the PID. Other than this, we better also monitor or control this manual value. We can right click this add watch, so that we can set this manual value. Okay, those are PID key values we need to monitor. And then let's go to the simulation. So for the simulation, we can monitor this noise enable, so that we can give a noise or disable the noise. So click this add watch. And now this PID mode, that is automatic mode. Let me switch to manual mode first. So we can give a manual value to this manual synchronized value, this input. And this PID output can be controlled by this manual mode. So firstly, I can write, double click here, it will automatically pop up this. We can select the manual mode and click this transfer write value. Okay, we write this manual mode to the PID. And this is the PID manual control. So we can write, let's say, 30%. So watch this PID output. If I write this 30%, so the PID output will direct control by this 30% value, manual control value. So once we set this 30, we will see this process feedback is changing. So that means this simulated model is working now. So we can wait for a while, waiting for this process going back to its stable status. Okay, we can leave this for a while, and every value is changing now. Okay, and this set point value, that 5 comes from this initial value. this set point value is come from its initial value. And from here, keep in mind, so far all those PID parameters, they haven't worked yet because those PID need to work unless we give an on this initial. So this initial will be on one cycle to initial those PID parameters. So we need to turn it on. We can double click this value. And once we double click, it will automatically prepare the true value to this value. We can click this write. It will write true one time, allows all those prepared value right into these parameters. Oh, once we write, see, so the PID is changed to the active mode. So actually here, we could prepare the manual mode as an initial status or prepare this auto in an initial status. So I'd better switch this PID to manual mode first. And write this manual mode to PID. So we can see once I write 30, so this manual will write to this PID output again. So we can leave this system working here. And meantime, let's go to set up the scope, the trend. Okay. Firstly, we can save this project, let the system run here. And then let's set up the trend project. In the TwinCAD system, to set up the trend, we need to set up another sub-project. And that sub-project, that is a scope function. Today, let's go to this project, right-click, and click Add New Project. And from here, let's select this TwinCAD measurement. Click this measurement to monitor this PID value change. So we will select this YT scope. YT means the y-axis, that is the value. The t, that is the x-axis, that's the time. If we need to monitor one function like x and y, we can use this xy scope. But in most of cases, we will use this YT scope project. And here, make sure we set up this project is the same directory as our main project. So that is this folder. Okay. And from here, we can set up TwinCAD measurement. We can name it PID. Okay. And select OK. And once we set up this sub-project, so we will see under this main project folder, this is our existing project, TwinCAD 3 PID project, and this, that is the measurement PID project, that is a scope project. And this is our main project folder directory, okay? All right, as we know, within one PID loop, there are three key values we need to online monitor. One is a set point, one is the process value feedback, that is the actual value, and one is the PID control. So we need to monitor those three values. We go to the data pool, right click, click this target browser. It will online browse the tags in the controller. So if you are connecting one actual controller, you can double click this controller connection and browse the tags from that controller. And now I'm using my laptop, so my laptop here is show green. And my controller, that is this 851. This 851 is assigned under the PLC properties. And if we double click this PLC project, here this PLC project, we assign that PLC port, that is 851. If we set up multiple PLCs here, so it will number like 851, 52, 53. It will line up as this. All these three values, they come from the global GVL, this global list. So I will browse this GVL, and those value locates here. Let me click. Firstly, let's set up this side point. And once I double click, this tag will be added under this data pool. And next one, let's set up the process value feedback. Is this actual value to scope? Double click. And next one, that is the PID control. Okay, PID control. Okay, double click those 3 tags and then they will automatically add it here. And quickly reveal all those 3 key values come from our PID control program. And this actual value to scope come from the simulated process feedback. And this auto scope come from the PID output F out. Okay. And then let's go to this YT chart. YT chart, that is our online trend, this table here. And then to allow this chart to show these 3 tags, we need to drag all these 3 tags into this axis group under here. So that means these 3 tags will use this axis in this chart. But as we know, the set point and the process feedback, they are the same unit. For example, the temperature, or maybe the speed, or maybe the meters, the length. But our PID output, that is the value from 0 to 100. So that means it doesn't have the same unit with those 2 tags. We need to set up another axis here. So we can click this. Under this YT chart, we can add a new axis. And from here, we can drag this PID output under this axis. So this allows, and this axis will show this PID output. This axis represent the values, the process value. Okay, we can rename this. This is a PID axis PID. Okay, this axis, that is the process value. Okay, so double click this process value. Look at the properties of this y-axis. And because our simulated process object, that is one temperature system, and it's an operating point that is 40 centigrade. So I will set up this axis range basically from 20 centigrade to 70 centigrade, so that this trend can work in the center of this chart. Okay, so I will set this y-axis, this axis process value, this axis here, and it's a maximum. I will set 70. It could be the full range of your feedback sensors. This totally depends on your application. And the minimum I will set, let's say 20. Okay, and then let's go to this PID control output. And this is the axis PID control output. Set this max and min, that is a max, that is 100, and the min, that is 0. Okay. Also, we can set the color of those trend. So set point, that is a green, and the blue, that is a process value. This ways we can set a little bit bigger. For example, the process value I can set 2. Okay. And the PID control signal, personally, I would prefer to set the red. Okay. Okay, I will set the red. Okay, basically, we finished the presetting of this chart. We set the color, also we set the range of this y-axis. And then to online monitor those values using this trend, to enable this online monitor, we need to find out this button. This button maybe locates different area, so we can drag this to the right side of this bar. Okay, let's click this. That means start record. If you cannot find this button, you can select this wheel. You can go to the toolbar and enable this Twincat 3 scope, and then this will show up. Okay, let's click this start record. So once it starts, we will see this y-axis, they will automatically change based on this value and based on the setting of this maximum and minimum. Let's show up this watch list. And keep in mind, this is a blue curve that is a process value coming from our simulated process. This green curve, that is the PID set point, but now, because our PID is working under the manual mode, so this manual will control this PID output directly, control this red curve. Once we change this output control, so this red curve will change, and then this blue curve, that's process value, will also change based on this output control. For example, now this PID manually we controlled 30%. If I change to 25, so because this is the temperature cooling system, so once I decreased this PID output, the temperature value will be increased. From the watch table, we can see that actual value, that value is increasing. And from the trend, this blue curve is increasing. It's just a little bit slow. And meantime, we can click this overview. So we can drag this monitor area if you online monitor this process change. Because like this temperature is changing very slow. So it's hard to see the change now. But if we enable the noise, we will see the difference. For example, if go to the watch table, if we enable the noise, click this, prepare the true, and let's write the noise. So we will see after I enable the noise, this process value includes the noise. We will see it's changing now. So as we know, this is the overall picture of this online trend. If you want to check within this area what the actual value of this process value, what we can do is this. So firstly, we can pause this trend. With the pausing behind is still working, we will see this value is still moving. Just this screen is paused. So we can move this window. We can resize this window and move this window. So you can resize this window. This window represents this area, how long and what the width of our time. We can move the window. And once you select this certain range, and if you want to check the detail value at that time, so you can click the line here. It will show at that time what the value of this curve. For example, you can click here, it shows that time this control value, that is 25. Click this, that is side point, the value is 5 at here. So it's very convenient. And we will see this online trend is still working. So once we click this, it will start continuously. And keep in mind, this overview will control this overview. And this max will zoom out. Once we click this, it will show the overall picture from the starting till now. And if you click this, you can move the trend left, right, up and down. Another key function from this scope I would like to show, that is the trend archive. So like here, I already have a long time curve here. I would like to save this online curve to an offline file. So we can go to here, click this stop. And in the meantime, the system will pop up. Do you want to stop? Yes, I want to stop. And if we need to save this online curved file, we can click this save. It will ask you if you want to append the scope date. So I will select no to choose a directory. For example, I will choose this directory and save this online curve data, name it as PID parameters, PID test, okay, and click save. And after we save this data, so to load this saved data, we can see here. Here, there's one green play, this icon here. So that means this YT scope project is used to online. If we want to load the offline saved data, so we can click this add this existing item. And meantime, we can select this PID test. I click this open. So it will ask us copy the existing data to the project folder. We click yes. So it will add this data here. Meantime, we will see this icon shows a different with this. So this disk, this yellow disk, that means this data come from the archived data. We can check out this change. Okay. All right, those are the key functions. Personally, I feel they are very essential steps for using this online scope or online trend, because this online trend is very essential function for PID commissioning. We need to use this trend to watch the process change and watch the PID control signals, this red curve and this dark blue curve. So the online trend is an essential tool and function if we need to do the online commissioning for the PID control loop. So in next video, we will set the PID working under the manual mode, and we will set a different value on this manual control, and we will monitor how this simulated process value change based on the different value of this PID control. See you in next video. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.